they stimulate mitochondrial biogenesis. They stimulate massive fat oxidation in the liver. And some people, they could be problematic for some people, and I think they could just tolerating like higher amounts of MCTs. So it's a little bit debated and very context dependent, and caffeine will actually enhance this quite remarkably. The conversion of MCTs to ketone bodies. So caffeine will enhance lipolytic enzymes in a way that accelerates beta oxidation of fatty acids in the liver, and then accelerated beta oxidation produces acetyl-CoA, which condenses to acetoacetate and then to beta-hydroxybutyrate. Those two ketones spill into circulation, and then they go to the heart, the brain, and the muscle as an alternative fuel. And then interestingly, and I did not know this when we started researching this, when you consume MCTs, a portion of it gets converted into ketones, but the MCTs also go into circulation, and these medium chain fatty acids actually can cross the blood-brain barrier, and they are in, for example, if you take out the hippocampus and you do metabolomics on it, there's a big signature of lots of MCT fats are getting in there. And I had to go, when we got our metabolomics data back 15 years ago, I had to actually jump on the call and go back to the literature. And it was a little bit fuzzy whether they did or not, but it confirmed, and now we know that MCTs, unlike long-chain fats from our adipose tissue or like the saturated fats that we eat in most animal products, short-chain fats can cross the blood-brain barrier too, but they do not cross the blood-brain barrier, but the MCTs do. So when you take MCTs, you're boosting your ketone levels, but also sending fats to the brain that can be used as an energy source by the mitochondria and neurons. So that is something I didn't know when I got into the research. Still, a lot of people, even lipidologists, maybe not know that. But it's really showing that these MCTs are kind of like the poor man's ketone ester. They are they're much more tolerable. MCTs are much more tolerable when you combine them with food. Taking a large dose of MCTs on empty stomach is generally not a good idea, even for me, someone who's pretty adapted to consuming a lot of MCTs. So MCTs are one type of saturated fat, and then I don't remember all of them. And lipidology is quite complex, but as we move up the chain to longer and longer fatty acids, they're essentially saturated in regards to all the hydrogens occupy the carbons, and they have a straight chain length, and the longer the chain length of the fatty acid, the more likely it is. So they all have different, these long chain fats not only are excellent fuel sources, and I feel quite benign if you are on a eucaloric diet, or even if you have a mild deficit, but in a surplus amount of calories. My opinion is that saturated fats, independent of medium chain fats, because they get used as fuel, excess saturated fats can be atherogenic. But when we're talking about ketogenic diets, most people use them tend to want to lose weight or be weight stable. Right. So, however, mainstream cardiology still feels that a low carb, high saturated fat diet is atherogenic, and I think the data supports that at this time.
So many cardiologists would tell you that saturated fats are atherogenic, period. But what you seem to be saying is, well, it depends on how much you're consuming overall, as well as how much saturated fat you're consuming. So if you're consuming excess calories beyond what your body needs, and a high proportion of those calories are saturated fat, then perhaps they can be atherogenic, but not necessarily in other contexts.